we I think we already have like more than 50 participants today, this morning, and I believe that there will be more that will join us soon. Okay, good morning, ladies and gentlemen. Welcome to the third session of SinarKU, the DSGE workshop. And for today, we will gonna discuss about the application of the model of DSGE to the fiscal policy analysis. In the first and the second session, we have already done discussing about the theoretical view of the DSGE model and what is the advantage of using the DSGE model on the analysis. And then in the second session, we learn how to work on this model by using the Dynamic and also the MATLAB. But in the third and also later on the fourth session, we will discuss about how to practically using this model to analyze both fiscal policy and monetary policy. But this morning, we're going to discuss about the application of the DSGE model specifically on the fiscal policy analysis. And I believe this is very important to use these tools because currently in the current situation of pandemic everywhere, not only in Indonesia, but almost part of the world, the using of a fiscal policy to expand the economic growth, to stabilize growth in every part of the world is very important compared to the pre-pandemic situation. So I hope that our discussion today will have a very greater impact, not only to us as a participant, but also to many policymakers in Indonesia or in any other part of the world. Okay. So for today's session, we will have two honorable speakers. The first one is I want to welcome Professor Nora Trump from SEC Montreal. Welcome, Professor, to Indonesia. I'm really sorry that currently we can't directly meet you in Indonesia, but I hope that soon, after the pandemic are better, we can directly meet Indonesia to attend the workshop, to do the workshop directly in Universitas Gadjah Mada. And then the second speaker, we have Mbak Sekar Utami Setiastuti, who from Faculty of Economic and Business, Universitas Gadjah Mada. And I think before we start our discussion, I need to read some rules regarding the flow of these workshops. Okay. Right. So there are 4 rules that need to be read. The first one is every speaker need to read the material, need to share their the workshop material for about 45 minutes, and then after that we will gonna have a Q&A session for about 30 minutes. So in total we will have a 90 minutes for hearing the lecture from our honorable speakers, and then it will be followed by 30 minutes Q&A sessions. And the second rule is for participants, if you have a question regarding the material that come from the speaker, and also if you have any other related question about fiscal policy, please you can ask the question by writing at the Q&A chat box, and the speaker will either directly answer in that Q&A box or directly answer your question through the Q&A sessions. And the third rule is please, for the participant, please make sure that you already turn off your microphones, especially during the speaker sessions. And the last rule is for all participants that join in the all session of SinarKU DSGE model, please please fill in the attendance form so that you can have access to the e-certificates. So I think that's all the rule that we need to pay attention during these workshops. Now, I think because it's already time, I will welcome our first speaker that come indirectly from the Montreal to have a very insightful material to share to us today. I welcome Professor Nora Trumps, Ph.D. Please, time is yours.
Thank you. All right, sorry. We're going first, I realize I need to get myself set up. Okay. All right, so I think you guys can see my screen. If not, let me know. I don't have a clock in front of me, so just fair warning, please, somebody else, you're in charge of keeping me on time.
Yes, I will help you.
All right. Okay, so today I'm going to talk to you about fiscal limits, which is related to defaults and government debt buildups in particular. So as was already mentioned, in some ways we don't need, with the pandemic, some discussion of why government debt is on everyone's minds these days, perhaps. Following the pandemic, we've seen across the world large increases in debt. But the other thing about this to keep in mind is that these are trends that were going on pre-pandemic. So really, if you look back at the data since 2010, in both advanced and emerging market economies, there's been increasing levels of debt. And this has been not just for government debt, this is true of also private debt levels. But today I'm only going to speak to the government side. So here's some background on where we are. But the other side going along with this is that while there's been increases in government debt, there's been declines in interest rates. So my graphs got a little cut off, sorry. The left scale of this graph that you're seeing is for advanced economies, and the right side you're seeing is for emerging markets. So it's true for both groups that we've been seeing on average decline in interest rates for government debt payments. But the difference is that still, if you notice for the emerging markets on the right-hand side, there's been still accompanied by increases in the interest rate burden. So interest payments on debt are going up, even though interest rates are declining. Why is this? Well, if government debt is rising sufficiently quickly, then your total interest rate burden can still go up, even if your interest rate's declining. Okay, so this is also to say, coming out of the pandemic, we're going to be in different starting points for these two groups of countries going forward, because on the one hand, when you hear a lot of people talking about research from a true advanced economy perspective, they have in mind these pictures where interest rates are declining, interest payments are declining, we're at a point where we can spend. But that's not necessarily the case for everyone. So you look at these graphs, or I look at these graphs, questions that immediately come to my mind, two in particular. When you see these different debt to GDP ratios across time, well, how sustainable are those? How sustainable is it to have certain levels of debt over time? Perhaps also you're looking at these graphs and you start to get a little nervous thinking, oh no, these are really high. Does this mean we should immediately start austerity measures? So when and how should we start having consolidation measures? So I just want to be very clear up front. Today's talk is about question one: how sustainable are certain debt to GDP ratios? And by no means, please don't take this as an endorsement of we should all embark on austerity measures today, because austerity measures have their own issues. The how to do those is a whole nother discussion. That's again a whole, you could do multiple talks on how successful those have been in the past, what different methods imply. So that's another toolkit that maybe Sakar is going to get into. But I just want to say, I'm going to focus today on this first question. How do we think about how sustainable are different debt to GDP levels? Okay. So in general, when I think about different sustainable levels of debt to GDP levels, what I have in mind in the back of my head is something called a fiscal limit. So in general, any economy, any country faces a fiscal limit, which is kind of a point of no return. So it's a point for either economic or political reasons. You're no longer able to adjust to pay for debt through either taxes and spending or through monetary policy. So all of these options are kind of off the table. And at that point, you're left with truly a default option, okay? So fiscal limits in general, people think of are nonlinear and state-dependent objects. So showing you here is a graph of a hypothetical fiscal limit. So for various debt to GDP ratios, we have associated probabilities of defaults. And it's nonlinear in terms of these debt to GDP ratios. As you can see it for very low debt to GDP ratios, there's a very low probability of default. And then we get to some point where it starts to increase steadily, the probability of default associated with a certain debt to GDP ratio. So it's nonlinear. It could be state dependent. We don't see that from this graph yet, but we're going to see that. The other thing to keep in mind from this is that it also implies, right, these things are not predetermined. So it's not that once you get to an 80% level of debt to GDP ratio, that's it, you will default, that's a tipping point. These are probabilities of potential problems that are going to happen associated with different debt to GDP ratios. And those probabilities can change over time, depending on people's views, depending on economic outcomes. So we want to formalize all this. How do we think about how likely are these outcomes? So one way to think about formalizing this is what we've seen from past experience. So I just wanted to point out a couple of things that we've seen, not in default, but even just in terms of downgrading of investors. So investment ratings of government's debts for different countries. So the blue axis that you see on these, the blue lines, I should say, that you see on this graph are showing you where the ratings were for these government debts at different points in time. The green lines are the debt to GDP ratios for those countries. And the key takeaway is that there are two things that kind of were driving in the background some of these episodes of downgrades. Okay, so downgrades associated with risk of potential default, right? So you can look at one being about capacity, how much the agencies view these different governments as being able to service their debt over time, which could depend on their current economic environment. So for instance, you can see here in the past, Japan got a downgrade when its government debt was over 100% of its GDP, whereas Canada experienced a downgrade when its debt to GDP ratio was under 100%. So those don't always happen at the same level of debt to GDP ratios, even for similar in terms of development economies. But the other thing to notice is that, so Italy is an interesting case. So if you look at Italy over the 2000 to 2010 period here, you'll see there's a period where its debt to GDP ratio is really pretty stable. But over that time period, it still experienced multiple downgrades in terms of its rating. And why was this? Well, if you go and look, so this was by Moody's, they were saying that the problem was with its potential economic growth. So not its current fundamentals, right? But a forecast of what's its likely path going forward, all right? So two things that matter, its current position, but also what its likely outcome in the future. So what that implies for us are a couple of things maybe in our mind, how then to evaluate these likely outcomes. One is that if we just look at historical data, we might have trouble being able to come up with a broad idea of what's the probability of default, how likely are certain debt to GDP ratios going to be sustainable, because just looking at the historical data, right, that's backward looking. That would miss, for instance, this idea of these agencies saying, you know, in the future, it looks like Italy's not going to have economic growth and therefore not going to have large tax revenues, therefore not be able to pay off its debt over time, okay? So the problem is we need to know about going forward, what's likely scenarios. And so we just don't get that alone from history. And in addition, there's unknowns about this. So we're having to do some type of forecasting exercise as well. So broadly speaking, then the way we're going to think about things is through a structural interpretation. We're going to need some type of economic model, some type of structural analysis that is going to ground us in a framework that we can think about future scenarios. What about if we have this possible outcome going forward? What if we have another type of outcome going forward? We can look at different scenarios. We can weight those based on how likely they are, and we can make predictions in that way. So there's been a growing academic literature that uses different types of structural models to try to figure out tipping points, so to speak. So points where it seems debt will no longer be sustainable. I just listed here some examples. These examples come from two main strands of the literature. So one is based on a type of model called strategic default models. So strategic default models are models where the government itself is a optimizing agent. It's acting benevolently on the behalf of the households, firms, the citizens of its model to try to come up with when's the optimal point for a government to default. I'm not going to talk at all about that strand of the literature today. So I'm going to take a view of that strand of the literature can say very informative things for us, but it also has some trouble addressing issues such as what if you just had kind of some bad policy for a while, or issues even related you could think of to political considerations, tax evasion. So that's what I mean, for instance, by bad fiscal outcomes. Just when the government may not be acting 100% efficient or 100% optimal from the point of view of individuals as citizens. So because that there's these other considerations that could be there, instead, I'm going to work with the alternative framework, which I'm calling this fiscal limit framework, which we're going to elaborate on now. Okay, so the fiscal limit framework. So the starting point of the fiscal limit framework, everything is really coming straight from the government side, the government budget constraint. So I've got two equations down here. So you can see the first equation, this is just a government budget constraint. So what are sources of revenue for the government? Well, it's their primary surplus, what they're getting from taxes minus expenditures, plus any new issuance of debt that they have today. So the total that they have, what can they use it for? Well, they're using that to pay off the interest on previous debt that they've had in the future, had in the past. Where here we're just keeping things really simple and thinking of debt as always just being one period debt. So not worried about maturity structure issues. So if we iterate forward on this equation, we arrive at the second equation, the intertemporal government budget constraint, which is showing us that government debt is equal to your expected discounted by interest rates of all primary surpluses going forward. Okay. And this is really related to a standard asset pricing model for debt, that the value of an asset depends on a discounted sum of future dividend payments. Here in the context of the government, those dividend payments are surpluses. So we're going to use this starting point and just do a couple of small tweaks to this government budget constraint to arrive at what we're going to call a fiscal limit. So a fiscal limit instead takes this idea and says, okay, well, what if we just change what we're looking at on the right-hand side here? Instead of being about what we expect, what on average we're going to see in the future, we replace that with some notion of maximum surplus possible, where maximum surplus possible could be coming from maximum tax rates that you could achieve, either because you're at the peak of the Laffer Curve, or that's the most that's politically feasible, or it could be associated with some minimum level of expenditure, which could just be because you have to have that certain amount of payments at all times. All right. So we're going to replace it with those and then say, okay, if that's the maximum amount that's possible, then what's the level of debt that would be associated with that? And then basically the analysis is going to be about how close are we to that point? Okay, so it's related to this notion of fiscal space. If you've heard of that, distance you are from a tipping point. But here that distance is going to be in terms of what's going on in relation to our maximum point from this government budget perspective. Okay, so some things it's going to depend on also though, the realization of shocks both today and in the future, because this whole equation, this intertemporal government budget constraint you see, depends on what you think is going to happen in the future across all time periods going forward. So it depends not just on today, but what you think is going to happen going forward. Because of that, no magic thresholds, like I had said in the past, that's going to trigger defaults. It's going to depend on where we are. And it's going to depend on both private private behavior and policy behavior, so the two, and also the two's views. So you could think of another layer of this could be about information sets, how likely you expect certain outcomes, how likely both public and private individuals expect certain outcomes. Okay, so to talk about this formally in the model, walk through the simple framework that's due to be 2012 European Economic Review article, where it's going to be a pretty simple model. At the end, we could actually solve a lot of this analytically, but it's going to highlight the key components. And then from there, I'm just going to talk about extensions that are in the literature, possible ways we can use this to think about different dimensions on which this debt can matter. So at its core, this basic model we're going to look at first, it's going to be a closed economy model consisting of just households and the government. So households themselves, they do all the production internally, they have utility, then there's a government. There are lump sum transfers from the government to households, and they're financed with labor taxes and the government issuing debts. We're going to assume that lump sum transfers are going to follow a Markov regime switching process, where one regime is stationary and one regime is explosive. So what this is doing is it's allowing for the possibility that there are periods of time where transfers are just growing, it's explosive, and then it kind of gets into a different regime where it stabilizes and they become stationary around some level. Why we're going to include this in particular for transfers, so we could think about this for different variables, but transfers in particular, because we're trying to mimic the behavior that a lot of governments are facing today, an issue of needing to do more and more transfer payments, either for retirement purposes of government guarantees or through some government aids to certain individuals. But in general, these transfer payments have been growing over time. Healthcare expenditures, these transfer payments have been growing over time. So obviously then if we stay in this regime where transfers are growing and growing and growing too long, it could be problematic in that the only way we could be able to keep paying off our debt is if we either keep issuing more and more debt, so debt's growing really fast, or if we keep raising tax rates. And at some point, we're not going to be able to raise taxes any longer. And at some point, we're going to start to hit tipping points where we're not going to be able to keep raising and raising debts without individuals in the model getting nervous that the government might default. So we're going to look at that interaction. And then finally, talking about defaults. In the model, each period, there's going to be what's known as an effective fiscal limit. So this is going to sound very abstract, but as I'm going forward, so I'm going to give you this very abstract notion, and then as I go forward, I'm going to try to fill in a little bit more exactly what it means. So each period, there's a effective fiscal limit. So you could say a debt to GDP ratio that at that point, if the government is above that debt to GDP ratio, the government will default. If they're below it, they'll continue to make payments. Where does that limit come from, or that limit come from? It's going to come from a state-dependent distribution. This is a part that's pretty abstract, so just wait and it'll become more clear as we go through the model. Okay, so on the household side of the model, households are going to be simple. We have a representative agent. You can think of many identical agents in this economy. They live forever. They get utility from consuming a good or consuming leisure. Total time in the period is 1 unit. So any time that they don't spend on leisure, the rest that they spend for work or labor, that amount of time is going to be 1 minus L, 1 minus leisure. So they're maximizing their utility subject to their budget constraint each period, which just says total income has to equal total expenditure. So sources that they have for income, they have what they're going to produce. So the household itself is going to work and produce a good. So AT times, AT is going to be a technology level, AT times 1 minus LT, which is labor. You can think of that as just total output Y in the economy, which is taxed at a rate tau. So the household itself only gets to keep their after-tax portion of that. They're going to receive a transfer from the government, which we're going to call Z. And then they're going to consume each period. So that's going to reduce some of what they have available. And then with the remainder, what they don't consume, they can purchase assets. So they're going to have available to them the government bonds that the government is issuing each period. So each period, the government's going to issue, in this model, a real bond. We're going to abstract from nominal things for now. A real bonds at a price Q today that has a payoff of 1 tomorrow, assuming the government doesn't default. Okay, 1 unit if the government doesn't default. But as you can see from the last term here, the last term is telling you what the household's getting from all of its debt that it carried over, debt obligations from the previous period. So it's getting back what they had there, assuming the government doesn't default. So that's what this 1 minus delta term's doing right here. So if the government defaults, it may not pay back in full its debt obligations. It may only pay a fraction. So this delta here is going to denote the fraction potentially that the government is defaulting on. So if we solve the model, if we maximize with respect to consumption, labor, and debts, we get 2 standard first order conditions. The first is telling us that the marginal rate of substitution between leisure and consumption has to be equal to the marginal productivity of labor after taxed portion. And the second being a standard Euler equation on government debt, where you'll notice the fact that this 1 minus delta term is showing up in this equation means itself that because of this possible risk of defaults, of not being paid back in full, households immediately taking that into account and wanting to be compensated for that risk in order to hold government debt. So the equilibrium price of the government bond Q is going to reflect that potential risk, and it's going to depend on how that risk varies over time. Okay, so that's the household side. So last, the government side. So on the government side, we have a government that has a standard government budget constraints. So governments, each period is collecting tax revenues on production. It's issuing government debts. Then what's it doing with the sources of revenues that it has? Well, it's paying back debt, assuming it doesn't default. It's making transfer payments to the households, and it's potentially also consuming itself. So we're going to let GT be a level of consumption the government has. Labor taxes, we're going to allow to potentially respond to the level of debt that's out there in the economy. So this is the way that we're going to try to keep debt under control. Is debt slowly growing? Labor taxes are going to have this response to gamma. They're also going to increase. So that's going to keep everything stable. But depending on how large this parameter gamma is, and depending on how quickly the government's issuing more and more debt, it may not be enough, as we'll see. Government spending, we're just going to make exogenous, and then transfers, as I said, we're going to assume follows this 2-state Markov regime switching process to capture this idea that transfers could go through these periods where they're just growing over time. So they're going to, this non-stationary component, and then a different second regime where it's stationary. And then the last thing, transfers, we're going to allow also them to have a counter-cyclical response. So you could think of A, remember, is technology. So representing, say, a structural shock in the economy. When A decreases, production is going to go down, income is going to go down. So in that case, when A decreases, we're going to potentially allow through this parameter of zeta Z for transfers to increase. So we get this counter-cyclical fiscal policy going on that we can also evaluate how much that matters for outcomes. Okay. And then finally, turning to defaults. So each period where, as I said, there's going to be underlying limit to debt, how much the government's willing to finance. And if today current debt obligations are above that limit, they're going to default partially. So delta here is going to denote the fraction of debt on which the government's going to default. There are different ways we could come up with a number for that. We can make that itself a random variable, so it's not guaranteed. You could think of how much the government's going to default on. That kind of goes through strategic negotiations between creditors and the government over time. So it could be a known, not known a priori. Or we could just calibrate it to a certain value. Both have been done in the literature. For now, it's just think of it as we are going to calibrate it to a specific fraction, say 20%, a haircut of what is going to be taken away. So then the object that we really care about is this last one, this B star. So this is truly the limit, the point at which the government's going to say, if I'm above that point, I'm going to default. So this B star, the limits, we're going to assume comes from an underlying distribution that itself depends on the state of the economy. state of all the shocks that's been realized, our technology, our government spending, and that transfer process, where we are with transfers. And the question now is, how do we determine that distribution? So how we determine that distribution gets back linked to things that I said earlier about, well, we want to think about what's the maximum amount the government's going to be able to sustain over time. And to think of that, I first need to start thinking about, well, what's the maximum sustainable with tax revenue? Once I start thinking about tax revenues, that gets me into this world of thinking about Laffer curves. So this is a hypothetical graph of a Laffer curve, in case we need some reminders, right? Laffer curves are this idea measuring that if you go from low tax rates and increase the tax rate, that's going to increase your tax revenue. But at some point, there's a tipping point where if I'm at already a really high tax rate and I start increasing tax rates, tax revenues are actually going to decline. And the reason for this is because if I'm at really high tax rates and I tax individuals even more, individuals are just going to say, well, forget that. Why am I going to work for such a low amount of a return for working? So instead, they're going to consume leisure instead of working. So there's this trade-off of keeping people willing to work to increase their revenue. Okay, so in our model, there's a well-defined Laffer curve for this labor-leisure trade-off. As a side note, for not all taxes do well-defined Laffer curves exist. If you're curious, I'm happy to talk about that later as a technical thing. But even if they don't always exist, you can still use the same type of framework, think about the same type of notion of getting to maximum points. Just take some tweaking of how we talk about some of these things. Anyway, for us, a well-defined Laffer curve exists. Laffer curves exist on this labor-leisure trade-off dimensions. You can think of yourself, if the government taxes you 100%, you're probably not going to work. So there's not going to be any income from work. There's not going to be any tax revenues. Okay, so I'm going to define tau max and T max to be the maximum tax rate and tax revenue that are associated with that peak point of the Laffer curve. And then basically what I'm going to do is go back to this intertemporal government budget constraint notion that we talked about before, we saw before, kind of a hypothetical one. This is now the one for our model, where I've replaced what we saw before about that infinite product of interest rates with using the household's Euler equation to get us to what it would mean in terms of household's utility function. So pricing that asset. So what is the interest rate in terms of how households value the interest rate or interest rate relative to price government debt, assuming there's no default. So this is in a world where going forward, we're not defaulting, okay? Because that's precisely what we're trying to determine. What level of debt is sustainable if going forward we don't default? And I'm gonna replace the notion though with just not thinking about it for any world we're in, but a specific world where we're at the maximum point. So associated with that maximum level of taxes, okay? So this is state dependent. It's conditional on our current level of technology and government spending. So if we're at a very low level of technology today, we've had a series of negative shocks that have made productivity really low. And that point, tax revenues are already low. It affects how likely you're going to be able to get a high amount of tax revenue, right? So where you are today in terms of what's feasible, in terms of tax collection, in terms of production capacity is going to affect what this amount is. Takara looks confused, so hopefully I'm making some sense. You should ask questions if I'm not making any sense. Okay, so this is the idea of what we're after. So it's an object we could calculate. This is an infinite sum of given. If I told you today the certain level of technology government spending is what transfers are, and I told you the maximum level that's possible of tax revenues, tax rates is given by these things, then you should be able to calculate for me what are different levels of this B star. So what are different infinite sums of this right-hand side object for different paths of technology, government spending, and transfers going forward, right? So notice this right-hand side depends on all future values of technology, government spending, transfers. So you could hold government spending transfers fixed if you want, think of those as a minimum level and just see how it depends on different economic environments, or you could let those vary as well. I'm going to let everything but tax revenues vary. But I need then to come up with some path of those variables. So I can calculate this object given paths of these variables. So the idea is that I'm going to do that for many different paths. So I have already, because we made a well-specified model with processes for technology, with processes for government spending, processes for transfers. We already said, right, transfers follow this Markov switching process. So I can come up with the probability already that you're going to observe a certain sequence of transfers or sequence of government spending or sequence of technology. So basically what I'm going to do is come up with sequences of these variables, feed those into this right-hand side and calculate this right-hand side object. And then I'm going to call that the level of debt that I would get for that path. How likely is that level of debt? Well, it's dependent on how likely were those sequences of technology, government spending, and transfers I calculated. Okay, so the probability of that sequence of events that we're going to calculate is going to dictate the probability that we're going to have certain levels of debt. Okay, so that's what we're going to calculate. So some specifics of how it's done. So we're going to give a specific functional form to our utility, so then we can get exact calculations for our first order conditions. With those, we can calculate tax revenue. So I'm going to blow through some of this, but you could go back and do it if you want to see the details. Once we have tax revenues, we could figure out what's this maximum tax rate possible, right? By just finding out what tax rate tau maximizes this object. Once we've got that, the maximum tax rates, we can plug that into our tax revenue function to get the maximum tax revenue that's possible. So now we have already for these things, depending on given levels of technology, given levels of government spending, we know the path of, we know the values of what's sustainable going forward. Okay, and then in practice to do it is just what I said. What we're gonna do is just run lots of simulations. So we're gonna simulate a whole path for technology, spending, and transfers. Specifically in this paper, B did it for 200 periods. And then we're going to calculate this right-hand side for those values. We're going to repeat it a large number of times. And that whole amount that we get coming out of that, we're going to call that the likely levels of debt B star that we could get, okay? So that gives us a distribution of what's likely levels of debt that are sustainable. Now, the last step of linking that back to what was happening in the model, if you notice, or back when I was talking about this model, I said we were just going to draw B star from this distribution, which means each period, actual default, this idea, if there's actually going to be default in the model, it's a bit random. So it's based on underlying economic fundamentals in that there's a distribution of debt levels, and we can calculate how likely those debt levels are. But in the model itself, whether or not you default today is a little random because I'm going to take a draw from this distribution, and that becomes effectively deciding whether or not I default. The reason we're doing this in the model is a couple of reasons. One, because it makes default actually possible in the model. So this is a model where you do observe default in periods. But more importantly, because it's tied a little bit to this notion of there is an uncertainty, there is political considerations, there's economic uncertainty, events that make the exact timing of when a government might default not really known to the public, okay, to maybe us as the model builders thinking about how this thing works. All right, so that's the idea of it's the whole model. And now with the model, we can look at what are the economic implications, probably the part you guys are more interested in. So we're going to look here at a couple examples. We're going to have a baseline calibration for all the parameters, and we're going to look at how things change depending on the values we look at. So what I'm going to show you is just, I'm really going to focus on these bottom lines. So these bottom lines are cumulative density functions. Or you could think of it as those fiscal limits like I showed you in a graph earlier today. So this is giving you, for various debt to GDP levels, what's the associated probability of default, basically. That's what it's telling you. And you'll notice that, and they're calculated from the model. So it's calculated just the way I said a minute ago. We ran lots of simulations in the backgrounds for different states over time, and then calculated based on those states, how likely it is that you would see those states, and then how likely you're going to see a certain level of debt. Okay, so these are our underlying potential limits for debt to GDP and their associated probabilities. They are state dependent, first big takeaway from the model. So for instance, if today technology is low, meaning our production is low, we're in a recession, that lowers, that shifts down this distribution. That makes it more likely that at any given level of debt, we're going to default. However, you'll notice there's still always a safe region where default is really unlikely, or this potential limit area is really unlikely. So it's only once we get to certain levels above 120% of debt to GDP ratios that this even becomes a concern from this model's perspective. If on the other flip side, if we're in expansions today, that gives us more space. Production's high, tax revenues are high. It's far less likely that we're going to be in a situation where we're going to need to default. We have more room. We can sustain larger debt to GDP ratios in general. The second graph is showing you the same idea, but this time varying government spending. So we're keeping technology at its average level in the economy and saying, okay, what if instead we're at a point in time today, the red line, where we have low government spending. So if we're not spending a lot today, that's going to raise our capacity. We're not spending as much. We're not using as much for expenditure. So we have more room with our tax revenues to pay off debts. We're more likely to be able to pay off interest payments going forward. We can sustain higher debt to GDP ratios. Whereas the flip side, or for high levels of government spending, it's distribution the other way. It makes it more likely that we're not going to be able to keep making our interest payments always, and that this limit point comes for lower levels of debt to GDP ratios. So one thing to notice from the model is that actually in terms of these two different things, the structural shocks, so the things that are really more about production itself, have bigger impacts than the direct side of the fiscal side, what's happening with expenditures. Some other ways we could look at variations. So the next graphs here, so in the background, these dashed lines are the same things we just looked at for the productivity case. So in other words, they're repeating this graph in the lower left-hand corner right here, okay? But as a comparison points. But now we're looking at how some other things vary. So particularly transfers. So this case, the case on the left-hand column, is looking at a case where we introduce this idea that we could be in regimes where we have just exponential growth, so to speak, just growth in transfers. Transfers are exploding over time. They just keep growing, growing, growing over time. That gives a real shift to this distribution. So far we've only been having just movements left or right, but this one changes the entire slope. It makes it more probable, right, that even at lower levels of debt to GDP ratios, could into potential situations where it's not sustainable, so that the probability of default starts to increase, so to speak, even for these lower levels of debt to GDP ratios. The top versus the bottom panel, that's just changing the starting point. So both cases are cases where you can go to this explosive transfer idea over time. But case one, the top panel, is where you start not in that situation today. So you're in a stationary world with transfers, but you know in the future, they could start becoming explosive. The second case is instead where today you're already on that explosive path and everyone knows it. And you'll see the difference is really in terms of this lower bound. It's expanding. If you already know you're on this path that seems explosive with transfers, they're growing, they're growing, they're growing. It's like debt's going to have to keep increasing, increasing, increasing. It starts to really lower what debt to GDP ratios are feasible. The other ones on the right-hand side are just varying steady state values. So if meaning in the long run, on average, what's our government spending to GDP ratio and transfer to GDP ratio. And again, these have some effects. So actually what they're doing relative to the baseline case, they're making them cases where we lower those levels. So if you lower spending, you lower transfers overall, you're going to have more room overall. The debt to GDP ratios raised dramatically. Okay, so last thing on this, what's the difference in this graph versus, say, the transfer path? So this bottom graph, the transfer path is about, I know in the future, transfers are just growing, growing, growing. Whereas this last graph here is a difference, a comparison of on average over a long amount of time. Okay, so steady state notion of the model. I know that transfers started out high 15, 16% of GDP. Instead, now we're at 8% of GDP. So this would be like some real long-term fundamental shift in what the government's doing, right? They just totally change how much they're spending in general on certain things. And for the unforeseeable future, they're always keeping with that notion. So that's why it's giving large changes in what's potentially feasible. But it's a notion I'm trying to stress. It's a little bit harder to think about maybe of what in reality happens with policy packages, right? Policy packages are more kind of the first column type of questions. Okay, and the last one, a couple more experiments we could do. So this is looking at, say, about the process itself. So as we said, technology, what's driving whether we're kind of in periods of expansion, recession, in terms of our production capacity in this model. That is coming, it's exogenous, it's a stochastic process, it's just following an AR1 process. So we could say, well, what if we change that process itself? So for instance, the bottom panel changes the dotted lines, our original case, which was with a standard deviation of 0.02. What if we increase the standard deviation? We just make it more uncertain what's going to happen in the future with our productive capacity, okay, technology. In that case, it's shifting the distribution both ways, both tails. It makes the whole distribution more uncertain, right? Like how feasible different debt to GDP ratios are, depending on your state today. If you're in low or high levels of technology, or you could think of it more, you're in recession expansion states. Why is this? Because it's just increasing the overall uncertainty in the economy in general. Where any level of technology today, it's more likely I can move farther from that point, good or bad directions, higher or lower values. And because of that increased uncertainty, it's just making it more unlikely. It's expanding the range of what's possible outcomes. Okay. Okay, so that's the idea of how the model works with the fiscal limits. The last step we could do with the model is, so this was showing you exercises of calculating in the background that fiscal limit, that notion from the government budget constraints. We could go back and solve the whole model, so we can collect all the equations in the model. I'm going to skip this slide, I think, in terms of time, unless there's real interest for me to go back to this. But so we can solve the model numerically. Since it possibly has default, we could solve the full nonlinear model, which was the case of what was being done in this paper. So this is some background details of how that's done. And why might we want to do that? Well, because in addition to them being able to make graphs like the bottom panel here, which is pictures we've been seeing, so these fiscal limit distributions, we could also compare how those are relative to the top graph, which is about equilibrium price. So this is telling us the top panel is for different debt to GDP ratios, what's the likely associate for given levels of technology. Again, so if we're at today a same level of technology, steady state level, or lower high values, we keep everything else fixed at steady state levels. What are the likely net interest rates associated with government debt, which we can calculate coming from the price for government debt that's being paid. And we can see how the interest rates relate to what's going on with this underlying fiscal limit distribution. So you can see that in general, interest rates, they tend to be fairly flat, constant, depending on the debt to GDP ratio, when we're in areas where there's really no probability of default. Okay, so if there's no probability of default, in other words, interest rates, they're really not dependent on what the current debt to GDP ratio is. The minute, though, we start to have some risks of default, that depending on where we are with the debt to PD ratio, same thing happens. We want to be immediately compensated for that risk. Remember from the household Euler equation, they didn't like that risk. That would mean they don't get back their full payments of government debt. So they want to be compensated to hold government debt since there's some risk of default, which means interest rates have to rise. So you can see interest rates start to rise. And what tends to happen is the interest rate, how quickly they rise, the slope here, inherits what's going on with this slope from this fiscal limit distribution. So you can see this case, how they kind of move hand in hand, which also then could tell you about some of those other cases that we saw before where we had more, slopes that had longer tails and such. Interest rates, what their past would look like and how they depend on government debt to GDP ratios would kind of mirror some of that. Okay, so they tend to move together. All right. Okay, so that's the basic model. So now in terms of where we could go with this basic model, well, there's lots of ways. Basically, now it becomes a framework of what specific questions are you interested in and how can you apply it to that fiscal limit framework? Meaning, do you want to know, for instance, how much foreign investors' preferences or their information sets or their worrisomeness about sentiment about emerging markets might affect these fiscal limits? Do you want to know about how a package that you might be considering today in your government might affect going forward these fiscal limits? Do you want to know how, if there's a structural change in the economy itself, if there's demographic changes in the economy, for instance, how will that affect the fiscal limit? So we could just start, in other words, to tailor the model along certain dimensions, maybe to address the question that you're asking about. How does that matter for fiscal limits? So I'm just going to mention a couple dimensions that people have talked about. So this is showing actually some calculations again by B, but using pretty much the same model framework we just saw, where she calibrated that model framework for many different countries. So in the paper itself, there's results for both developed and emerging market countries. She didn't have Indonesia. I would have loved to show you Indonesia, but I haven't seen this done for Indonesia, so I apologize for that. So I tried to pick some countries that maybe were of closer interest. So as you can see, these are results for Brazil, China, and India relative to what their debt to GDP was, the solid horizontal line, their debt to GDP ratios in 2016, which was the end of her data for what she used to calculate these objects. And so I'm not showing you at the same time the developed country ones that she's done, but relative to those, the difference is these debt to GDP ratios tend to be a little lower. So for instance, you can see these are already in the ranges of debt to GDP ratios that are above, for instance, China's level, not China, Japan's level, that are above European countries such as Italy's level. So they tend to be lower. And they also tend to have larger ranges. All right, so if you were worried about lower bounds, the range on them tends to be larger because there's normally more uncertainty that's associated with these economies in terms of their possible futures going forward. If you don't like that statement, if you don't agree with it, if you think there's low uncertainty, that would mean these bands would tighten. Okay, so if you think you know that with more certain accuracy what the possible path is for a particular country, that's good news. That means you're going to just be able to make these bands shrink some in terms of when you make your predictions. Okay, so other possible extensions. I don't know, how am I doing on time, just to have an idea?
You have all the time.
I think it's, yeah.
Oh, really?
Okay, I think it's very interesting. So I think it's just
oh, okay, well, I don't have a whole lot more.
Yes.
I could have skipped a little bit, or I could have, okay.
Yes, of course, we can continue.
Okay. So some ways you can go from here. Just like, let me talk about a couple different things. So one is more closely related to how I've worked on these things myself. So B and TROM have a couple of extensions to the framework that we've seen with B, where they take a step back. We took a step back and we said, okay, the picture we saw of these fiscal limit distributions basically are a logistic function. They have that shape that looks like a logistic function. So what if, instead of going through all this pain of trying to take a stand on maximum tax revenue, or what that fiscal limit distribution looked like relative to the underlying economics of the model, so doing those forecasting things I said of simulating a bunch of times the paths of variables going forward and calculating that object, what if we just ignore all that for a moment and we just say, this idea of if debt today, so what we called B star a minute ago, I'm calling it S now. So this notion of this limit of debt today that the government's willing to have. And if we're above that, we're going to default. And if we're below that, we're not going to default. It just comes from an exogenous logistic function. Okay, so that's what's this bottom part here. And what I mean by that is the probability associated with these defaults. It's associated with, these underlying values of S, which is associated with default, is a logistic function. Not dependent on any economic fundamentals at all, just not tied to anything. So why did we do this? Because from this starting point, actually, we then said, okay, we'll estimate this. We estimated for some countries using historical country data, what these logistic functions might look like. So how likely are certain probabilities of default? So again, not tied to any model fundamentals, not tied to anything per se, just estimating based on data we see of, say, debt to GDP ratios, based on interest rates, risk premia. We didn't do it, but you could also, for instance, add credit default swap information. So based on information of how likely it is that creditors want to be compensated for risk, we're going to estimate these parameters of this function. And then what we did is we said, oh, now an estimate of the data of this logistic function. Let's tie it back to this economic limit. So this is the economic limit we saw before, coming from, again, that intertemporal government budget constraint with an idea of we've replaced with maximum amount of tax revenues that's possible, and it's dependent on states of the world going forward, so technology, government spending, transfers. So this we could calculate from the model. We've just seen that. So we took a model, we calculated what this object would look like from the model, and we compared it relative to what we got not using this structure in the model from the data. And we said, okay, the difference between the two, that's this additional point here, this beta pull, or we call it beta political, that didn't exist in what we've seen so far earlier at the model. So what we did is, in order to make the two work, get the one just from the data relative to this one from this economic structure, then the match, we said, what value of this beta do you need to make a match? If beta was 1, that would say that the model lines up perfectly well with, let's say, investor sentiment in the data, or what we're seeing in the data. If it doesn't match, so for instance, if it's less than 1, which is what we find, there's further discounting. What could that be? Well, it could be one of two things, really. We think of it. It could just be investor sentiment. Investors themselves, for whatever reason, more heavily discount. But if you don't think of it as sentiment, what could it be? Well, it could be tied, again, to things not in this model. So for instance, political factors. This object we calculated earlier from the model was based on truly maximum amount of tax revenue that's possible from this Laffer Curve notion, which is true economic limit. But you may say governments actually can't get to true economic limits. For instance, Greece, when it was doing austerity measures, there were lots of riots in the streets. People didn't want to accept these things. So it may not be feasible for a government politically to even get to some of those economic limit points. So this notion can represent that. So we estimated this for Greece and Italy, and we found discounting for both. For Greece in particular, this beta parameter was well below 1. So there's heavy discounting that we want relative to the model point. Okay, a couple last things. Everything I've talked about so far has been in a closed economy environment. Maybe for you guys in particular, you're looking at this and you're like, well, that's not useful at all. That's missing everything that we care about. So let me say a quick word on open versus closed economy. Closed economy, in a sense, is good news because it turns out you can think of closed economy as a lower bound for the open economy. Why is this? Open economy, if you think of open economy pricing for debt as coming from risk neutral investors, foreign investors. Risk neutral foreign investors, all they're going to care about is just risk of default. So they're going to price debt just based on this probability of default instead of what we saw before, where since they were also potentially getting the benefits and the risks of debt, they care about how that relates to their consumption growth profile from a utility perspective. In general, the covariance between this default portion and our consumption growth profiles, or the marginal utility growth profiles, it's positive, particularly when default probability is high, okay? So what that means is, since that term's positive, that increases the Q, the price that you're going to get. So shown here, the graph now, you're seeing the interest rate that comes out of the model with the closed economy for a particular case. So this is with the fiscal 50% chance of probability of the fiscal limit being at 147% debt to GDP ratio. If instead we were in an open economy, that price falls for any given level of debt. You see, interest rate falls given level. Instead, to get us back to the interest rate that would be associated around the same level of debt to GDP ratios that we saw in the closed economy case, the open economy case, for 50% probability of default, it would raise to 152% debt to GDP ratio. So that's what I mean by closed economy in some sense gives you lower bounds. So that's good news in a sense that you could just work with that. Okay, so final thoughts. So I've been talking about a very simple framework for the model. As I said, there's lots of different extensions of directions you could go. Some that may be of interest in particular to you guys if you were really thinking about how to use this or how to apply it in different contexts. Let me just talk about a couple. So one in particular that I think is nice, there's this paper by Corsetti, Kuster, Meyer, and Mueller. For a new Keynesian model, so they've added nominal dimension to the model, first of all, in monetary policy. But the other thing that's interesting and useful about this application is that it's actually a much bigger model quantitatively. And if you see a very big model quantitatively and you think about defaults, you might think, oh my God, how are they going to solve this? If I have to solve a full nonlinear model with quantitative methods, that can get really cumbersome. But they do it using a perfect foresight solution. And doing this, for instance, you could use packages like Dynair to actually solve and to think about what the model would look like under different scenarios. There's been, I know, a few papers coming out of various authors with applications in Europe in particular that have been using this same line. So just to say, it's not that these methods have to be full on really, really rigorous, crazy quantitative methods at all, just to use some of the insights. Some other applications. So there's a nice paper by B, Shen and Yang that is particularly focused on developing in countries with a significance of looking at valuation expectations, how possible devaluations, how buildup of expectations of a devaluation affect fiscal limits. And they show that there can be significant effects. There's an application by B, Leeper, and Leith, which again is with the new Keynesian model that's highlighting how this default risk or these fiscal limits can end up putting a constraint on the monetary authority. So the ability of a monetary authority to stabilize inflation and say output or unemployment, or this trade-off between inflation stabilization and say output employment stabilization is augmented with higher risks of default or being at this farther along in terms of, or closer, sorry, to this point of the fiscal limits. And so that can make it harder for a monetary authority. So there's the linkage, that consideration. And then again, in terms of other types of frameworks, that this has also been extended to a monetary union framework. So you could think by a paper by Andres, Burel, and Shen. So you could think of that framework as then giving you another way of thinking of a more open economy context between two regions. Their application is particular to a union where you've got one monetary authority across the two regions, but you could tweak that modeling framework to get you to a situation where you're looking at two regions with their own monetary frameworks as well, or real economy frameworks. So that's all I was gonna say. Hopefully some of it made sense and it's not entirely confusing. But please, any questions you have or any thoughts, happy for all of it.
Thank you very much for sharing us very insightful information and also knowledge about the application of fiscal policy by using the DSGE model. Thank you very much, Professor Nora Troms. Okay, and then the second honorable speaker for today's session is Mbak Sekar Utamistuti from Department of Economics, Universitas Gadjah Mada. So for Mbak Sekar, time is yours.
All right, first of all, I should thank Nora for coming. All of the slides, all of the materials took me back when, in graduate school, you just try to learn everything, and computationally, it was very, very, I mean, if you want to, okay, the baseline model is very simple, but if you want to try to put a lot of features, put new Keynesian features in it, or probably create an open economy version of it, it's becoming like a headache if you want to solve it fully non-linear, because I actually didn't talk about dynamic programming in a previous session, but you know, it was probably all of the attendees could learn more about it. It's very interesting in terms of like, you know, you can work with fully nonlinear model. You should kind of like, you don't have to linearize everything, and but the trade-off is it's going to be very computationally very hard and cumbersome. But anyway, so I'm going to talk about something that's I think we're going to pull all of the questions in the last session, right, Mas Tahika? Right. So
yes, Bhaskar.
Yeah. Okay.
So
sure.
we will start our Q&A session just after your sessions.
Okay. Okay. So everyone can start typing question for Nora. Anyway, so I'm just gonna talk like quickly about the things that we've been doing in our macroeconomics working group. So the idea was kind of like learning what's happening during the pandemic and what's the fiscal policy, what is the most effective fiscal policy that could be implemented. Now that we have a lot of things going on, we have new transfer to the household, we have a assistance to the small, medium enterprises, we have a payroll tax cut and so on and so forth. But what is the most effective, in a sense that, you know, we don't try to predict, but if this kind of thing happen again in the future, we can actually deploy something that is effective. You know, the thing with fiscal policy in Indonesia is very discretionary. So any changes with the fiscal deficit and things like that, it has to go through the House of the Representatives. So the inside leg and the outside leg is going to be so big. In terms of like automatic stabilizer, that's not, well, it's kind of like, it's going against whatever that we learn in graduate school, that automatic stabilizer is actually kind of like the best way to stimulate the economy. All right, so I'm gonna share my screen. Hopefully everyone, can see my screen now. First of all, I have to give a disclaimer. Don't cite anything, don't quote anything. This is all work in progress. And I thank GIZ for the funding that we get from for the research and the capacity building training workshop that we're doing until the end of next year. All right, so the idea is very, very simple. As I said before, we're trying to model fiscal policy during a pandemic. So this model is, you know, we just replicate Paria and Castro 2021, just recently published, and we calibrate the model to Indonesian economy. But we expand the pandemic to include the second wave in Q2 2021. So the nice thing about the model is that you can model a pandemic, you can kind of like capture the idea that pandemic is not only going for like one wave, but you have multiple waves. So we're gonna study the effects of different types of discretionary fiscal policy. The setup is very, very simple. I'm not gonna go through like a detail of it. If you're interested in this, you can just go to his paper and read the detail yourself. I'm just gonna give like the overview of things or features that put in the model. So there are two types of household. There are worker borrowers and owner savers. So borrowers earn income from employment, and savers are kind of like wealthier agents that owns firms and banks. Workers can be employed or unemployed. If they're unemployed, they're gonna receive unemployment insurance, or if they work, if they employed, they're gonna earn some wage from working. Now the thing is that we don't have unemployment insurance per se in Indonesia, but we do have Kartu Prakerja, which you could think of it's kind of like the like a very a very simple version of unemployment insurance. So we're still going to put the unemployment insurance data, Kartu Prakerja data into that instrument, but as we know, the value of it, the nominal value of it is very, very low compared to other type of stimulus. So, and there are two sectors. There's service sector that is kind of like contact intensive. If you can think of like, you know, hotel, restaurant, tourism, transportation, you know, all things that required, customer and firms interaction. And then there's non-service sector, which is not directly affected by the pandemic. So the most important thing that we have talked before is that you want to model the macroeconomic phenomena. You want to model the crisis. You want to model what's happening in this economy right now. And it really depends on how we see it, right? If you ask me what is the pandemic, what's the source of the pandemic, what's the shocks, then we might have different views of it. You can think of like, oh, it's a total factor productivity shock for a fact that with when you were working from home, we don't have a lockdown, like a very strict lockdown, but we do have a lot of people working from home. With one capital and one labor, you're going to have like less production in a month because you're working from home as opposed to when you're working at the office. So you can think of it like, oh, probably it's a total factor productivity shock, then real RBC model is enough to give you a view of what's happening during the pandemic. But and there's a lot of people that's like, it just doesn't make sense because it's a lot of things are happening in the epidemiology side. You don't want to work anymore, so there's like a like this utility from working, because when you go out to work, then you're going to contract the virus and so on and so forth. But you can also think of it as a sudden stop or like a shock on a contact intensive sector. So if you look at the GDP data of Indonesia, the sectors that contracting the most are, those are, as I said before, like tourism, transportation, all that kind of sector. So, but the shock that's happening in that service sector is going to kind of like propagate into non-service sector through the aggregate demand externalities. Okay. So what's nice about Miguel's model is that you don't just see the pandemic from the household perspective, but you also have a production sector, again, service and non-service. You're also going to have banking sector, which is going to be affected directly from the household that are not able to repay the debt, right? So it's going to create a disruption in the financial sector. And then itself, it's going to amplify the recession. Okay. So the scenario that we do is we have shocks that last 6 quarters until Q3 2021, because that was the biggest wave that we had so far in the pandemic. Fingers crossed, we're not going to have another wave. And that would result around about like 7.5 to 8% of unemployment rate. So we talked about this before with my fellow labor economist friend, Gumilang. Why is it not, why don't we have an unemployment rate like in the US, more than 10%, 15%, or even in other countries more than that? I think it's the idea that people are searching, people are still searching for work, but then you have also that margin of people that are in the informal sector. I think that's something that's going to be very worth doing, expanding this model into include informal labor, because we do have a lot of informal labor as a fraction of the labor in the labor market. So the complete story, it looks like this. So it started from a very large shock in the service sector, and then that create a big drop in employment in that sector. Borrowers are going to default because of the credit market frictions. Going to be high interest in lending. That's going to affect the. If we talk about like a credit market friction, you have good borrowers, bad borrowers, and that affect everyone's that going to borrow money in that economy, because banks are constrained in that sense. And then that going to create a decline in non-service consumption. That's going to create, reduction in inflation, demand for non-service sector, and so on and so forth. So Miguel's paper has this zero lower bound that's put into it because it's, he modeled that for the US economy, but we don't have that in this model. We're just going to use Taylor rule, just standard Taylor rule. All right, so Again, I'm not going to go through all of this because we only have like 40 minutes left in the session. So if you want to read like the detail of it, you can just go to the paper and then read all of the details, derivation. Not a lot of derivation, but at least you get the sense of what's happening there. So as I said before, they have two borrowers. Sorry, in that economy, there are two borrowers. There's two household borrowers and savers. So borrowers are subject to what we call cash in advance constraints. So the real business cycle model that we had before, we learned before, it doesn't have kind of like money in the model, but that money could be modeled into like, different type of setup. You can have money in the utility, or you can have like money as a way that means for transaction. It means that before you buy anything, you have to hold money. So, and then they're also going to be subject to a liquidity shock. The total cash in hand would depend on whether they're going to work in the service sector and non-service sector. Plus, if they don't work, then they're going to have unemployment insurance. They're going to have transfer from the government minus the tax that they have to pay. So the agent decide to default when they don't have enough money to repay the debt. So there are a lot of non-linearities in the model. So the model is being solved using perfect foresight solution. It can be easily done using dynamic. Okay. So the threshold for the two possible states, because you can either work, you can either be employed, or you can either be unemployed. And that depends on the wage, the after-tax wage, and then the tax, the lump sum tax that you have to pay. If you're unemployed, that's going to depend on unemployment insurance and the transfer that you get from the government. Okay, so the borrower solved the following problem. It's a bit more complex than what we learned in the previous session. But in general, this should not be, I know this, some people are like, oh my God, well, what is this thing? It's so scary. Believe me, the first time I saw it, it was like, what, 9 years ago in Dr. Fiore's class, actually. No. I was like, oh my God, what is this? But, it's just a way for us to model the household behavior, right? We want to maximize our lifetime utility subject to a budget constraint. Now, you can either write it using the notation, the equation that Nora showed us before, or you can write it in a kind of like a dynamic programming setup, and you're using what we call a Bellman equation, right? So that just says that the household maximize their utility and the continuation of that value function. Subject to a budget constraint. So on the left-hand side, that's basically just all of their spending, and the income is on the right-hand side. So the spending are for consumption and paying the debt, or repay the debt. 1 minus F, that's the F is to the default rate. And then you have on the right-hand side, that's basically all of their income from working from in the service sector, non-service sector. And if they're not employed, if they're unemployed, they're going to get unemployment insurance, UI, right? All right, so that's that. And then they're also going to be constrained. They don't just have that the budget constraint, but also borrowing constraint, in the sense that if you want to borrow some money, then you have to kind of like, there's like a threshold, or like there's something that it cannot exceed that threshold. Savers do the same thing, but in savers problem, they actually enjoy consumption from the service sector. It's different than the non-savers or borrowers problem. So they also derive utility from the service sector. They're gonna have, on the left-hand side, of course, they are gonna buy consumption goods, the service consumption good and non-service. And they're also gonna buy government debt as a mean of savings. They're also gonna deposit some money to the banks, right? So now you have two different agents, because if you have only one agent that wants to borrow, then loan in the credit market, it will be in equilibrium, will be zero because everyone wants to borrow, no one wants to supply the loan. Now you have two different households that would achieve that. So savers deposit money to the banks, and then borrowers are gonna borrow the money from the bank, right? So we have also a financial intermediary in the model. So, and then you can derive the demand for services. Now, the banks is the financial intermediary. It's gonna be modeled, it's modeled using Goodler and Karadi. That's a very kind of like well-cited paper. If you look at the financial, like banking sector type of literature, you know, macroprudential literature, this model is pretty simple in the sense that, you know, you have this bank that does financial intermediary, but you don't have like interbank market. You don't have like the retail versus like the wholesale branch of bank. So it's very simple. So the bank, what they do is they take deposits from the borrowers and give the loans, take deposit from savers, sorry, that's a typo, and give loans to borrowers. And they're gonna, the intermediation process is gonna be subject to two type of frictions. The value of the asset of the banks cannot exceed the market value, and the bank should pay 1 minus theta fraction of the earning as dividend, okay? So those are like here in the constraint. Now, the interesting part is that now you have two production. You have non-service sector, and then you have a service sector. It's very simple. It's like the thing that we learned before. The non-service sector is subject to price rigidity. It's being modeled using Rothenberg pricing, which takes me back to my prelim. And then there's a service sector that is modeled as a perfectly competitive. So it's so prices are flexible. And there's the interesting part is that there's endogenous entry and exit, means that the mass of the firms, how many firms in that economy will be changing over time depending on how the pandemic pans out. Now, the value, sorry, the firm, as we said before, if you look at service sector in Indonesia, well, most of the input of production are labor, right? And that makes the service sector, if you look at the price rigidity, would have a higher rigidity than non-service sector, because the input of that, the input in terms of labor has more rigidity. If you think of like wage is very rigid, right? Having this price flexibility in the service in the service sector is something that's kind of like, you know, do you want to believe that that's happening? Probably not. And this is kind of like an automatic extension of the model that we can actually do. You know, put a price rigidity in the service sector for the fact that the price in the service sector is more rigid in general than in the non-service sector. And then wage is going to be defined by a reduced form rule. By you know, you have to take account of the labor in the service sector and non-service sector. The central bank follows the standard Taylor rule. The fiscal policy, you know, we have a government budget constraint that looks like this. On the left-hand side, that's the spending. On the right-hand side, that's the income. You know, you get the government get the income from the payroll tax, taxing the firm for the profits, for the dividends, and then they issue debt. And also, you know, if you look at the expenditure, they have a government consumption. They have expenditure on unemployment insurance, you know, repay debt, also transfer to the household, and also you have the firm's assistance. So liquidity assistance for the firms affected by the pandemic. And if you look at the text is gonna just follow the standard rule. I think Nora knows this paper so well. And then we calibrate some parameters. Say, for example, discount factor for savers. We calibrate it according to the data for real interest rate, which is around like 6.37% on an annualized rate. Discount factor for the borrowers is generated by the steady state. And then we have a borrowing constraint, fraction of borrowers that also comes from the data. Rothenberg minimum cost that's generated from a Calvo pricing around 0.5. Again, we're doing an empirical test. We're doing an empirical paper to look at what is the duration. From that duration, using aggregate data of Indonesia, using that duration, we can trace back what is the Rothenberg minimum cost that we should use in the model. So we're not only just building the macro model, but also doing a lot of like micro empirical paper to support this paper. Now you also have the employment at the steady state. Nora mentioned this before. This is just like a long run value of employment. Trend inflation also is generated using 100 Prescott filter. Government consumption as a ratio of GDP, and then we have a government debt at a steady state. We have a fiscal rule parameters and labor payroll tax around 5%. So this is the PEN program. So Pemulihan Ekonomi Nasional. You have the government spending. That's a percent of GDP. Q4 2019. So that's a nominal value. TB, that's the transfer to household. That's the UI, which is very, very small. And then we also have the transfer to the firm. So kind of like liquidity assistance. But the thing is that we don't get a very accurate data for Q1 21, because I assume that, if you're looking like, if you're looking at the first quarter of each fiscal year, you have a government consumption, all types of expenditure that is actually low if you compare it to other quarters in the year, right? So you have this massive fall from Q4 2020. Now, what that caused is that it's very hard for us to generate the unemployment rate that match the data of unemployment rate, because as mentioned, as published by BPS, in Q1 2021, the unemployment rate is actually falling. But if you look at the stimulus that being given by the government in Q1 2021, the model kind of like wants to push the unemployment rate up, even without the shock. So this is something that we have to, fix, probably something in the model, probably, and it's only happening for government consumption. Like if you look at like the transfer to household, transfer to firm, we don't have this problem. So you have to look back, look at the model, and kind of like understand why does the effect of government consumption is so big as opposed to other type of stimulus. Now, in general, if you wanna for a DSGE model, macro model, the first thing is that you have to look at what are the effects of total factor productivity shock, right? It's kind of like RBC type of the type of prediction, but it's it's just to make sure that you are modeling the economy correctly. All right, so what are the effects of total factor productivity shock, and what are the effects of monetary policy shock, right? So by the way, that shock that we generated, that was the one to kind of match the unemployment dynamics during the pandemic. So we take that shock and then we do what are the effects of that pandemic, what are the effects of that shock into this economy. So you can look at the effect to GDP, consumer borrowers, labor of service sector, non-service sector, wage in both sector. You can also look at the effect on the default rate, let's say, and inflation. Right, so this is the counterfactual without the policy. But what if we have a policy? Suppose that you have that pandemic and only you have a government consumption as a fiscal instrument for stimulus. Okay, so there's nothing interesting here. There's the differences, but they're like pretty small. Again, if you look at the transfer to household, it's going to be pretty similar as well. Interestingly, the highest the highest difference is generated by unemployment insurance. So if you look at the counterfactual, by giving the unemployment, by deploying unemployment insurance, you can actually kind of like stabilize the borrower's consumption and also their income. Right? If you look at also from the wage of the people, so wage of worker, not people, wage of worker in service and non-service sector, they're falling, but they're not falling by much. If you look at the GDP as well, there's a kind of like, I give a cushion in terms of like, okay, now we have a crisis, but we're not actually falling. The contraction is not too bad. Now, the interesting part is that then you can measure, you can estimate the fiscal multiplier given the shocks that you had before, and given all of the parameterization, calibration that you did before. Now, this table compares the normal versus crisis period. As you can see here, during the normal period, without the pandemic, government consumption gives the biggest multiplier for horizon ahead. So that's like in a year, in both employment and GDP, right? But if you look at the crisis period, which is in the bottom panel, you see that the multiplier for unemployment insurance is going up pretty significantly from the normal versus crisis period. So employment and GDP multiplier is still going to be generated the highest from the government consumption. But if you look at other type of instrument, it's actually going up, and the biggest increase are in the unemployment insurance multiplier. Now, if we increase the period to be 20 period ahead of, so this is a multiplier of 20 period ahead, you can see that the effect of UI is long lasting. It's actually bigger than if you only look at the 4 horizon. It's even bigger than 1, while the government consumption is actually falling lower than 1. If you look at the multiplier to income, it's getting even bigger in the 20 period ahead. And in terms of GDP, unemployment insurance could also generate a multiplier that is closer to 1. Whereas if you look at other type of instruments like income tax or unconditional transfer, they consistently have a lower multiplier throughout the horizon. Now, so there are caveats from this analysis. It's very simple. We took a lot of shortcut. As I said before, there's a lot of interesting feature that we didn't put into the model. And pandemic is modeled as a sudden stop of demand in the service sector. So we're looking into how do we develop a model into something that's more interesting in terms of like matching the feature of Indonesian economy. Let's say, what if we have price rigidity in the service sector? What if we have government investment? It's not really relevant per se to talk about government investment during the pandemic, but it's still being a part of that government budget in general. In APBN, we have belanja barang modal. That might be really interesting as well to see. And then we're gonna try to put informal labor in both in service and non-service sector. It will be very interesting if we can, well, hopefully, create kind of like endogenous rate between formal and informal labor. Interaction of fiscal and monetary policy, that's very interesting as well, because the central bank for the first time is doing QE. The central bank is buying the government bond in the primary market. So in terms of discussion of whether that policy is good or not, effective or not, deployed during the pandemic, it's something that we can do in the future. All right, that's all I have. If you want to read the paper, please do. I have the references written here. Thank you so much, Mas Trahika.
Thank you very much, Mbak Skar, for giving us insight about the fiscal policy in Indonesia, especially during the COVID-19 pandemic. Okay, now we can move on to the Q&A session. I think I've already seen one question. Can I read this? So, related to the government model, also mentioned labor tax. Please explain what is meant by labor tax, how the labor tax can contribute to a model of government, such as in the construction of a government model building with the underlying theory. Thank you.
Is it for Nora? Is it for me?
I think for all speakers, I think, because they don't mention the speakers' name. Yeah.
Okay, Nora, you want to start?
Sure. So what is a labor tax? So a tax on the wage in. Oh, I'll give you the short answer is tax on wage income. Your salary tax. More accurate answer in terms of the data is it's an income tax. So it's really about all parts of income that are normally taxed. That's the connection we tend to make, meaning, you know, you pay some on interest payments of debt, you pay some if you have capital gains on stocks, you have your wage income, salary income. That tends to be the largest share. So it's not too far away to call it just the wage income tax in terms of the data. But in the model, that's typically where it is. Did I answer the question? It's cargo.
Yeah.
I think you answered it perfectly. I don't know what to add. Do you have any, is there any other question? If not, I'll ask Nora some questions.
No,
it was so interesting. not yet?
Not
All
yet,
right,
yeah.
okay. So it's something that's really interesting. If you talk about fiscal limit in developing countries and you see how the economy is really different in the developed countries, you know, all of the tax things. How do we model tax evasion into this model, to the fiscal limit model? Because I think it's very important for kind of like for us to conduct a tax reform if it's gonna, you know, create a problem in terms of the fiscal limit that we're having. Yeah. Yeah,
it's a good question. There's a couple ways you can go. So one way, I mean, there's some papers on this idea of formal, informal economy, thinking of informal economy as more of a black market type economy. So that's one, or at least the untaxed part of the economy. So sometimes tax evasion is just modeled through that setup. I mean, that you've got a formal, informal. Informal is not taxed. So if you do certain policies that, so for instance, you raise tax rates, what you might be doing is causing people to shift into this informal, non-tax sector. So you lose tax revenues in that way. So I haven't, I'm not seeing anything done with the fiscal limit with this, but there are in general for the DSGE models, right? There's some papers that have gone that direction a little bit. And then with tax evasion itself, there's different ways you can think about that. I mean, are you talking, where is the tax evasion? Are you talking about it in terms of on the firm side, households income? At what level are you talking about the tax evasion? And so where would you want to model it? Some of that's about, I think, understanding what areas are most significant, which is challenging to know where are they not paying.
Coming up with the data for that is also very challenging.
Yes.
So yeah, I think when you talk about like the shift between formal and informal sector, I think it's going to be very relevant to the case of Indonesia, because now during the pandemic, people are not working in the formal sector anymore, but they're kind of having like an outside option that they do to, you know, still earn living. So I think if we can model, you know, the shift between formal, informal, back to formal, and put it in the fiscal limit, I think it's going to be very, very useful in terms of like studying the dynamics of Indonesia, let's say, or like developing countries in general. All right. Okay. Yeah. Thank you. Do we have any more questions?
I can't see yet, Mbak Sekar, in the chat room, but if it's possible, I can ask question to Nora, because I'm a bit curious about the fiscal limits model that Nora explained in the first session. So if you don't mind, I want to ask about the case of aging population that especially happen in the advanced economies such as Japan and perhaps in some part of European unions. So do the aging population problem can have impact on the fiscal limit for each countries? Because if we talk about aging population, I know that it's still not a big issue in Indonesia, but if we take a look on the regional level, particularly in the rural area or maybe some municipal that located outside the capital of Indonesia, outside the Java Island, some municipalities that are located in the borderline between Indonesia and Malaysia, I think there's some problem of aging population there. So my question to Professor Nora is, do aging population can have some impact on the fiscal limit in each countries? And if there is some impact, how can we incorporate this problem into our model? Thank you.
Great. Yeah, it's a great question. At a very reduced form level, that's kind of what, when I was talking about this explosive transfer path, the idea. So aging population that then is going to require retirement payouts from the governments. That's a transfer payment. So if you have, as you age, then you're going to have, I mean, as aging increases, to say if the retired population is growing, then the transfers are going to grow. So that's a notion of why maybe you would get on that explosive path. But that leaves out, so I said reduced form because it leaves out a lot of other dimensions where you could think aging in particular could be having an effect. So it'd be having effect on the workforce, and then working capacity, production capacity can be having effects on overall savings. So yeah, there are different dimensions where it could be interesting to look at the population effects. You can put population into a model. There are some, I could give you some references if you're looking, but there are some papers that have looked into this with these modeling contexts of, and you can have it growing or shrinking and thinking a little bit about how that works. The challenge can be in terms of if your model then is stationary or not, right? We like to think of things in stationary terms, but it's a possible thing to play with.
Yeah. Okay. So for all participants, if you have any questions, you can write it down on the Q&A box.
Or maybe you can unmute yourself and ask the question directly.
So Carla, unemployment benefits, your multipliers may get even larger with the formal informal sector, because you may be giving even more reasons to move into the formal sector. So
yeah, so that's what we're thinking, because now do we want to, like, in terms of like a national policy type of discussion, do we want to have more labor into the formal sector, or, you know, we keep it like fluid between formal and informal, like giving the unemployment insurance just only to the formal sector? Would that be a kind of like incentive for people to stay in the formal sector? Yeah. Okay.
In the model, it will be, I think.
Yeah.
But you could go look at, I mean, so I don't have good example. I mean, I know you could look back at past country episodes, I guess, where they introduced this and see. I don't know much myself on this, but you could check what's been the results they found on that. Yeah.
So for participants, if you have question in Indonesian, please you can write in the chat room, and I will help you to translate. Yeah. Sorry for speaking bahasa. Jadi jika Bapak Ibu sekalian ada pertanyaan, nanti bisa dituliskan dalam chat room. Nanti saya bisa bantu untuk terjemahkan, bisa untuk ke Nora atau untuk ke Mbak Skar.
Nora, I have another question, but it's not related to what you presented before. So, what do you think of unemployment insurance in terms of like, we think that it's going to be very costly to cover for that in terms of crisis period. But in general, what are the kind of like barrier to have unemployment insurance if you want to start one?
Barriers. I guess I would say barriers are just the startup fiscal side costs. I don't see. What's the argument? The argument is about the incentive, right? Oh, give me a second to remind myself this argument. There's an argument on the job search effort trade-off, right? That if you're, because yes, that's I guess the negative argument people give is that you're causing people to reduce their search effort because now they don't have a reason. I'm not sure that there's been even, I mean, this was even the big debate in the pandemic, right? With some of this extension of benefits that were done in places like the US, Canada. And there were lots of people writing on this, but I don't think even for those cases, there's been any definitive proof that it's led to that, meaning I don't think the negatives have won that argument. So.
Okay, so it's just like the cost of starting the whole program that might be big, but if you do a counter-cyclical fiscal policy, you keep like having a big kind of like a.
It's the commitment. That's right. You're committing yourself to that cost.
Yeah.
So there's that. But I mean, there is this. You can get in the models, right? This effect on search effort and your willingness to take a job. So there's that side too.
All right. Thank you.
Bhaskar, we got one question more from Alec Naik Martua. How we know the goodness of fit model that we built?
I would say, I mean, all models are approximations, first of all. Sometimes I scare myself looking at how much of an approximation they are. But I mean, at the end of the day, you're trying to look at it relative to some data. So for instance, data moments, how volatile are certain series you see in the data, such as GDP over time? Does that match what you have in your model? How well does it fit certain features of the model? So if you put in an experiment like Zakar showed, you put in a path, can you replicate then the path of variables that you see in the data? So I would say these are our ways of measuring goodness of fit.
Yeah, and I feel like if you can estimate, always estimate. I think I showed the estimation using Bayesian to the attendees last week, Nora. But if you can't, then find a good parameters. I feel like that's what you do. And good parameters, sometimes you need good microeconomic data to support that. So microeconomic research and macroeconomic research is not something that's completely separated. You live in the silos. But yeah, so I feel like good calibration, good parameters, and also if you want to do estimation, make sure that the parameters that you get from the estimation make sense. You don't have like beta equals 0.01, let's say, or we can just like just model non-forward-looking household in the first place. But anyways, yeah, as Nora said, sometimes it's always scary to look at my model and like, oh my God, there's just so many things that I don't take account. A lot of parameters that I'm not really sure that this is the correct one, or is it going to be able to match the dynamics of the Indonesian economy, etc. But you still have to build something to give yourself or the policymaker an insight of all of the macroeconomic phenomena that we're observing. So yeah, I guess it's better than none. Yeah.
Okay, maybe I'm gonna ask some follow-up question to Bhaskar. So in case of conducting the fiscal policy research by using the DSGE model in the context of Indonesia, what is the main challenges that you face when you conducting your research about the fiscal policy impact on Indonesia?
Data.
Related to the data. Yeah, okay.
Yes. I think we have some friends from the Fiscal Policy Agency here, Nora from the Ministry of Finance. We have a very close relationship in terms of like sharing the data. But sometimes when you talk about stimulus and the realization of stimulus, all different type of stimulus, be it in transfer to households, transfer to the small medium enterprises, tax cut and things like that. It's very hard to kind of like pinpoint. So because sometimes the realization is different than when are they kind of like put in the book, right? So probably the realization is in January, but then it's it showed up in the government balance in March, for example. So those kind of things are very, I'm not saying not very limiting, but reduce our confidence in the model itself, because the data we're not sure whether it's correct or not. So yeah, we're just gonna assume that the data it is what it is. That's what we got. But yeah, and some data are very lagging as well. If you look at like banking sector, like the banking sectors, let's say they have like 3 months or 4 months lag sometimes. So if you want to work with the banking sector inside that model, to model the default rate and things like that, you want to have a data to quarter 3 2021. Let's say it's not going to be available. So if you want to estimate, you can estimate it until like a quarter or 2 quarters before. But yeah, I think the main challenge of doing the DSGE model, well, in that case, also macroeconometrics analysis in Indonesia is the data. Yeah.
Okay. So maybe from Professor Nora, can you have a suggestion to us, the researcher in Indonesia that face difficulty in finding the correct data, or maybe the trusted, the valid data to work on this DSGE model, especially for the fiscal policy? So how can we tackle this problem of less available data in Indonesia?
How to tackle the problem of data limitations in using the model.
Yeah. So how can we fix that?
Well, long term, advocates for more data. But that's a very slow moving solution. Data is a true. If there's no data, it's a true limitation. It's a huge, hard problem. Because it's like full stop. That's it. That's what you have. So I would say, what has to be done at that point is you do the best you can. You go with what historical series you have, episodes you have. You go with what best practices you can for calibration instead. You go with similar countries' experiences if you can find them. So similar in composition or economic structure. If there's somebody else who has better data, then can you rely on estimates from their data for certain parts to inform related to yours? I do worry in general about sometimes, for instance, US-centric or Western-centric focus on the models, and that we do too much of that, and that there are true, in particular, when you think about fiscal policy, there are true differences in policies across huge sets of countries. And so, the results of one may not be the best starting point for another. So I think at that point, you have to go with what's your structure and do the best you can to fit that. Which it sounds like you guys are doing. That's great.
Yeah, but as you said, that it's kind of a slow moving to waiting for the more available data. But I think we can try to wait it and maybe find another another strategy to couple these problems.
Yeah, so adding to Nora's, give me like 1 minute. This is what I told my students, that, you know, being macroeconomist, it's very hard because you don't just get to have your subject inside a laboratory and then you just, you know, do experiment or, you know, get a household survey and do your own survey and things like that, because you're always limited to whatever the data the officials are, you know, publishing, right? So you have to be very resourceful, and this is what I'm learning as well when I was in my graduate student time. It's just for different type of questions, you know, you always have like different type of models, right? If you don't have the data, then, you know, you can't do macroeconometrics for sure. Then, you know, one thing to do is to build a model. But then when you build a model, you still need to estimate it, or you still need to do moments matching, right? But at least moment matching, or moment matching is still going to be kind of like not really heavily relying on the data itself in terms of like how many data available to you. In macroeconometrics, you have to have like 100 data points of observations, things like that. But with this type of model, you can actually do things that, you know, bypass whatever it is, difficulties that you have in macroeconometrics analysis. So Nora, I think the macroeconomic analysis in Indonesia is, you know, very, very heavy towards that time series analysis. And it's really great to have you here with us to show that there's something out there that we can use when we don't have the data to conduct the research as we wanted it to be, right? So thank you so much, Nora.
Thank you for having me.
Okay. So thank you very much for all of our honorable speaker for today's session. But due to the time constraint that we face today, so I need to finish up this session, and hopefully that all of us can learn many things from Nora and also from Mbak Sekar, that how to use the DSGE model for fiscal policy, especially if we want to do that in the case of Indonesia. Again, I want to say thank you very much especially for Nora, for agree to share your knowledge and also some information about the DSGE model for fiscal policy. So thank you very much for Nora and also Mbak Sekar. And also thank you very much for all of our participants in this today's session.
Thank you so much, Nora.
Thank you so much.
Thank you guys, really. It's a great thing you're organizing. So
yeah. Hopefully we'll have another more in the future. Thank you.
Right.
Thank you, Nora.
Bye.
Bye-bye.